Traditional institutional finance requires stable, verifiable collateral. For decades, rare and collectible coins have been rejected from this category because their value relies on public auction markets, environments driven by subjective aesthetic appeal, collector trends, and volatile daily demand. The ARISAI revaluation protocol is a private legal technology framework designed to bypass that market volatility. It replaces the subjective pricing of the open market with strict algorithmic mathematics. This graphic shows the protocol's core operational claim: the transformation of a raw coin valued at $300 into an ARISAI instrument recognized at $21,000. This $21,000 figure represents an engineered metric called the revalued market value, or RMV, calculated through an architecture known as the triad of trust. To understand how this valuation is constructed, we will trace a batch of 40 newly minted quarters through this exact pipeline to observe the math. This triad of trust diagram maps the ARISAI architecture, dividing the process into 3 isolated roles. Authenticated value is achieved by separating these powers. The numismatist evaluates the object, the assayer calculates the math, and the notary verifies the procedure. Dividing duties prevents any individual from manipulating the final record. The ARISAI protocol operates as a closed-loop contractual pipeline engineered for institutional finance, separate from retail flipping or public auctions. Institutional lenders underwrite based on predictable, legally defensible value. This protocol attempts to manufacture that predictability entirely from scratch. We begin at a local bank, acquiring a standard $10 paper roll containing 40 newly minted, dual-dated 2026 quarters. The protocol imposes an immediate operational constraint. These coins must be submitted for professional grading within a 30-day window from their official release. Industrial minting facilities stamp millions of metal discs under immense pressure, causing steel dies to degrade. Only the first batch of coins struck by a fresh die will possess flawless, microscopic sharpness before the tooling begins to wash out. Each quarter must be inspected under a microscope to call any pieces carrying factory scratches, bag marks, or dull luster. Only the absolute best, flawless specimens proceed. We will track this batch using an analytical dashboard. Our initial asset count is 40, carrying a circulating face value of exactly $10. Submitting the surviving coins within that initial 30-day window secures a first strike or early release designation. This label serves as physical proof that the asset was captured at its maximum aesthetic potential. By isolating these specific specimens and adhering to strict submission timelines, the owner upgrades the coin from a circulating commodity to a verifiable historical artifact. This graphic details stage 2 of the protocol, introducing the first gate of the triad, the numismatist, who establishes object truth. The numismatist operates in isolation. Their duty is limited to evaluating physical authenticity and surface preservation, with no input regarding the asset's financial value. Professional authentication requires an upfront capital deployment. A standard shipping and third-party grading fee costs roughly $30 per coin. Applying that fee across our 40 quarters, our sunk operational costs climb to $1,200. The numismatist completes the examination and assigns a definitive numerical score on the 1 to 70 Sheldon scale. For our example, the batch achieves a certified grade of 50. Establishing an unalterable, third-party verified object truth provides the necessary physical anchor before any mathematical leverage is applied to the asset. The physical asset now moves to the second gate of the triad, the assayer, the entity responsible for establishing mathematical truth. This diagram outlines the ARISAI revaluation formula, visualizing the strict algorithm the assayer is legally bound to execute. The system identifies the $30 professional grading fee as the base retail value, ignoring the 25-cent circulating face value. Input 2 is the certified numismatic grade, the score of 50 established by the independent numismist. The assayer executes the multiplier logic, $30 multiplied by the grade of 50, establishing a revalued market value of $1,500. Applying this verified multiplier across our full batch of 40 coins scales the total valuation of the asset pool to $60,000. Our dashboard now reflects the results of this revaluation. A $10 roll of pocket change has been converted into $60,000 of ledger-ready value. Isolating the assayer's math from the numismatist's grading is a structural anti-fraud mechanism designed to prevent financial kickbacks. This mathematical jump creates an immediate vulnerability, the potential for an assayer to invent numbers or execute math on unverified assets. This diagram of Stage 1 illustrates the final gate of the triad, the civil law notary, enforcing procedural truth. The notary executes multi-factor biometric identity verification on the asset owner. They then administer a sworn affidavit from the assayer, legally binding them to the mathematical calculation's accuracy under penalty of perjury. The finalized evidence package is locked, time-stamped, and irreversibly hashed onto the Comply Chain Guard distributed ledger. This Stage 5 graphic shows the result of that ledger entry. Blockchain anchoring finalizes the asset's transformation, moving it into institutional financial pipelines. The notary serves as the ultimate bridge in this architecture, fusing the physical object and the mathematical valuation into a single, legally recognizable package. We must address what happens if an owner takes one of these $1,500 quarters and tries to sell it at a local pawn shop or on a public auction site. The open market operates on consensus demand, and it will reject this valuation. The multiplier formula carries no weight with retail buyers. This graphic reveals the defining mechanism of the ARISAI protocol. It functions as a strictly closed-loop ecosystem. Every participant, borrower, lender, and underwriter must sign a legally binding contract to enter the network. Through an asymmetrical arbitration clause, parties surrender their right to debate the subjective value of the collateral. By signing, they establish the mathematical multiplier as the binding record of fact for the duration of the transaction. This creates a distinction between public fair market value and internal contractual value. Institutional lenders accept this framework because they prioritize mathematical stability and legal certainty over the unpredictable fluctuations of public commodity markets. From $10 of metal, $1,200 in fees, and strict notarial law, we engineered $60,000 of underwritten capital. The ARISAI protocol manufactures capital through the rigorous, unyielding application of contract law and cryptographic certainty.